we're going to go ahead and get started. Hello, everyone, and thank you so much for joining RIEGL's most recent episode of our Ultimate LiDAR webinar series. My name is Abby Clark, and I am the Marketing Manager over at RIEGL USA. I will be your moderator today on air and facilitating your questions during the Q&A session later. So please make sure to submit your questions as we go right here in the chat. Today, we are diving into all the news from INTERGEO that RIEGL presented and exhibited at in Stuttgart, Germany, just last week. We had some fantastic new product launches and developments from all segments, including Airborne, Unmanned, Terrestrial, and Mobile. Kicking this off first is Michael Sitar, who is the Division Manager of Airborne Laser Scanning at RIEGL USA. Take it away, Michael.
Thank you, Abby. Before I get started, I would also like to recognize my colleague, Mr. Peter Rieger, who is the Technical and Business Lead for the Airborne Division in Austria. He's provided much of the content for this presentation, so it'll be good to recognize him here. Okay, many of you may already be familiar with this slide, but I think it gives an excellent picture of the number of sensors and systems that are available from RIEGL on the airborne side. Whether it's compatibility with platforms, new applications. These sensors include hybrid large format laser scanners with internal high resolution metric cameras for wide area collection within an aircraft, multi-directional scanners for corridor and urban mapping applications, capable of supporting numerous imaging systems and configurations, as well as standalone scanners for custom integration with third-party peripherals and enabling technologies. Now, this isn't a comprehensive view of all our products. We do have pod-based solutions as well. Given the amount of time we have in this presentation, I don't wholly go into much on the topobathy side. Now, looking back at the model release history of the 1560 series scanners, the introduction of the LMS Q1560 was more than 10 years ago. It was an important milestone for RIEGL, as it was our first completely integrated airborne laser scanning system for wide area mapping applications. It was also the first system to introduce multi-directional scanning into an airborne system design, creating the now popular crossfire scan geometry for extremely effective dense canopy penetration, true ground detection with near uniformity with respect to the point spacing and density across the entirety of the scan. With the subsequent introduction of the VQ series scanners, RIEGL was able to offer a direct upgrade path for the first time in order to maximize our clients' return on investment by enabling direct access to future increases in performance without the need for additional sensor purchase. Such improvements included increases to laser pulse repetition rates, measurement range, collection efficiency, and area coverage rates, and also improvements in target resolution related to laser beam footprint reduction. More than 100 devices have since been sold worldwide, and the model line now continues with the new VQ 1560 Mark III's, a complete architecture redesign consistent with the VQ 12 and 1460 sensors that were released in 2023. Some of the key features associated with this new sensor include a complete redesign of the electronics platform, as I mentioned, enabling a 10% increase in laser emission rates from 4 to 4.4 megahertz, maintenance of the popular crossfire scan geometry, increased sample block lengths, which enable a doubling of the number of returns per pulse for increased vertical density as compared to the earlier Mark II's model. Elimination of the external LiDAR and camera data recorders with the integration of on-sensor removable disk storage, as well as a transition from the older SATA data formats to U.2, which provides a 5 times decrease in data downloading speeds. An on-sensor graphical interface for sensor parameter verification without the need for an attached laptop. And of course, compatibility with all versions of SOMAG's larger aperture GSM mounts, including the newly announced GSM 5000. So looking quickly in terms of the efficiency differences between the older model and the new, this chart demonstrates that area collection rate is generally inversely proportional to the laser emission rate, given the laser output power curve. So as the emission rate goes up, maximum flight altitudes typically decrease in relation to the energy density per pulse. Now looking quickly at the current Mark IIS sensor model, an operational example of 20 points per meter square can be effectively collected with an acquisition rate 385 square kilometers an hour, given the assumptions below in flying speed and side lap. Now, the 1560 Mark IIIS uses the same lasers as the earlier model, but with the supporting new computer architecture, we're enabling a rep rate increase from 4 to 4.4 megahertz. And this translates roughly to a 10% increase in emission rate and a small bump in collection efficiency from 385 square kilometers to 410, given the assumptions below in flying speed and side lap. The primary design effort was really focused on migrating the earlier model to the new architecture for production standardization with the VQ12 and 1460. And this, of course, provides future performance improvements, while in the process also eliminates many of the in-cabin components, such as the external data recorders. Now, when comparing the 1560 Mark IIIS to the VQ 1460, visually very similar looking sensors, they both are dual laser designs, but very different scan patterns. The 1560 Mark IIIS counter rotates and pitches the independent beams to create the crossfire scan geometry you see here from the interleaving of the two matrix scan patterns. And this has been proven to be extremely effective for vegetation penetration and really has endeared it to those looking for a sensor that excels in all applications, particularly those that demand vertical structural detail. Now, in the right image, you can see the laser apertures for each laser channel or beam path, and each aperture acts as both the receiver and transmit paths for the respective laser beams. So consequently, there can be some background noise or atmospheric points that may need to be filtered, which is really common for most all high-performance laser scanners on the market today, as pulse power and detector sensitivities increase. RIEGL has an on-sensor clutter suppression switch that addresses much of this phenomenon during collection. Now, the VQ 1460, on the other hand, produces a single matrix scan pattern from the two laser channels. And so you can see the ping pong effect in the matrix point distribution plot to the right. In this configuration, the transmit and receiver paths are completely separated, effectively eliminating any in-air atmospheric noise in the resulting point cloud, and producing extremely clean raw data sets not requiring filtering. So if you're having challenges with respect to smog or in-air particulate from smoke and whatnot, the 1460 really changes the game with respect to the amount of noise clutter that you might encounter in your collected data sets. The data is extremely clean based on the optical chassis design. So additional efforts this year with respect to the VQ12 and 1460 include the embedding of Phase 1's larger IXM RS280 digital cameras inside the sensor chassis. This camera configuration allows longer focal lengths for higher resolution altitude without sacrificing the area coverage rates for that camera, particularly as it relates to wide area applications. We have also successfully integrated the IGI aero control system with their high accuracy GNSS and INSS systems, as well as their CCNS5 flight management system. And this provides users with a choice with respect to their inertial and FMS preferences. And as of this presentation, we have delivered close to a dozen of the VQ 1260, 1460 next-gen sensors since its release last year. The VQ 680 multi-directional scanner that was released last year has also been successfully integrated and flight tested as an OEM product into the Vexel Dragon hybrid imaging system for oblique mapping applications. And field demos are actively in progress with both the OEM version in the Dragon and also, of course, our turnkey system version from RIEGL, which are now in full production. Additionally, the new VQ-IU data PC has been demonstrated to be able to simultaneously support up to 6 150 megapixel cameras at a 1.5 frames per second capture rate. In addition to writing LiDAR data on the provided removable U.2 SSD storage cartridges. And so this new component supports up to 16 terabytes of data storage space and will become the standard data recording unit for our multi-sensor payloads moving forward, particularly as it relates to our smaller sensor configurations as they're installed in pod solutions for both helicopter and aircraft platforms. And the embedded PC in the VQIU supports both Windows and Linux applications. Finally, RIEGL has released another version of its RIMAP software, version 1.3, a plugin to ArcGIS Pro that's available free of charge. This desktop software provides direct access to the RIEGL process project structures for data and mission management directly within the ArcGIS environment. The software incorporates web apps to search and query the mission projects, as well as dashboards for easy access to statistical project summaries. And this latest release of RIMAP now provides support to both ArcGIS Pro Online as well as the Enterprise Edition. And future releases will include the ingestion of image data to support the already implemented LiDAR data access. There are, of course, many other topo and BATH-related airborne initiatives not specifically captured in this presentation, as I mentioned earlier. So please reach out if you'd like for further information on that. And with that, I would like to introduce you to Ms. My-Linh Truong, Division Manager here in North America for Unmanned Laser Scanning Sensors and Systems. And she will spend the next few minutes introducing you to the latest announcements from RIEGL in the UAV sensor space.
Thank you, Michael, for that warm introduction. I would first like to take a few moments to acknowledge my colleague and counterpart over in Austria, Philip Ammann, who has supported in providing much of the new insights that I'll be sharing with you today. Not unlike the slide that Michael shared on the Airborne portfolio, I too have a similar portfolio lineup here. So I invite you to take a flight with me on our mini but mighty fleet. Of course, we have our MiniVux series, which is our smallest and lightest weight form factor, very efficient cost-wise. Moving up into our VUX lineup and going up further to the right side, you can see that there is some crossover between on the manned integrations as well as unmanned operations, but right in the middle is the sweet spot, and that's really where I want to take you on our journey today and introduce to you our new VUX 100. The new VUX 100 is very similar to something that you probably have seen before. It is the same form factor as our well-established VUX 120 system, same mounting points and everything. That includes the same accuracy, the weight at 2.3 kilograms, same number of returns that it can capture, and of course supporting the number of cameras. But what's really different about this new VUX 100 is that it has an increased field of view. It is 160 degrees with an optimized laser pulse repetition rate of up to 1.5 megahertz, so that in that field of view, it is 1.3 megahertz. What is unique about the VUX 100 compared to the 120 and 160 is that it is nadir and not the nadir forward backwards multi-look angle. And this is something that we find will fulfill a need to bring a lighter weight nadir scan mechanism to increase your operation for a wide area coverage with that large field of view, but who's really looking for that nadir rather than NFB. So if we take that into consideration for the full VUX lineup here, the key differences is pretty apparent really with that field of view of 160 degrees, optimizing at nadir operation as opposed to NFB, and with the maximum measurement range capability of the new VUX 100. This is really optimized for the small UAS operations that only want to operate with a highly accurate but cost-effective UAV system. For those that are looking for higher rep rate, increased laser penetration into dense canopies, looking for longer range for integration on not only a UAV, but flying higher, possibly integrating it onto a manned aircraft installation, that's when you're looking at the higher VUX units. But with the new VUX 100, we're finding that sweet spot for high accuracy and small form factor. As I mentioned, our Mini VUX series is our lightest weight configuration and introduced last year with RIEGL E, which stands for Location Orientation Component. This is RIEGL's first foray into offering our own MEMS-based GNSS solution. It's fully integrated into the scanner. There's no additional hardware or software that's required. It's fully enveloped within the RIEGL data processing ecosystem. If you'd like to take a look at a video, there's a QR code there. But I just want to make a mention that this was, of course, introduced last year, and we were awarded the 2024 WICMAN Innovations Award for this payload system. Taking it further and beyond, we're now excited to share our expanded RIEGL portfolio with the RIEGL F. This is a more highly accurate MEMS-based IMU GNSS solution. In this case, offers triple frequency compared to the RIEGL E, which is dual frequency, still very lightweight. And this IMU GNSS solution is fully available and integrated with the VUX 100 and of course the well-established VUX 120. Not shown here weight-wise, but it is also available if you're looking for a more accurate GNSS solution for integration with the Mini VUX series. So taking a look here at the performance data quality that you can get from the new RIEGL F, this is fully integrated with the VUX 120 as mentioned. Here you can see the amount of resolution that the VUX 120 offers with the NFB. And if we take a look at this pole in the top right corner, you can see the level of not only data coverage on this pole, but how tightly aligned everything is from that solution. Of course, with the VUX 120 and NFB, this is great on transmission towers, and you can see clearly the amount of the wires that are captured. And of course, we do have a large product portfolio as mentioned before. So of course, it's a matter of, well, which one makes the most sense for me or for you? And I would say that, of course, besides the size, the weight, and of course cost of the particular sensor, it does really depend on the application that you're looking to obtain. In general, I wouldn't say that there's a one size fits all, but it can be a one size fits most depending on what your needs are. So here I have a chart where each star, the more stars there are, it goes from good, better, and best. And with our fleet here, you can see that the Mini VUX is tremendous in its capabilities, very lightweight, it's entry level, and will get the job done. But if you're looking for something that performs a little bit better, higher accuracy, more returns that come from the sensor, and still that lightweight form factor, the new VUX 100 is of course a stellar option. And last but certainly not least is the creme de la creme of the VUX fleet with regards to the ULS integrations. And I would say the VUX 120 and higher will provide the same accuracy as the VUX 100, but of course, more penetration through dense canopy with the NFB. Now, of course, with the LiDAR sensors, UAV, of course, you're going to need a platform to put it onto. And we here in the US are working with quite a few different drone manufacturers. And with our vetted platforms that we see, it's really important to make sure that you're adhering to the different certifications that are out there, depending on the projects that you're chasing after. So here's just a small sampling of a few of the companies that we do work with and their product offerings. And we do take the compliance very importantly. So here you can see which platforms as of July are compliant on the various types of certifications. And then once you've determined which platform, of course, then and which payload that you've selected, it's always important to know how long that platform can fly for. And so here is a sampling, really the maximum flight duration of those platforms for the integrations. And of course, this is really that maximum flight duration. So of course, that max value does depend day to day, depending on the environmental and operational conditions. But this is a good benchmark to get an idea on really what is the scope of your average project size and which platform may be ideal for that. Of those UAV platforms listed before, those are all multi-rotors. So of course, I just wanted to showcase that we are collaborating with a few different VTOL platforms as well. And here you can see just a sampling of those that are in operation. So I wanted to thank you all for joining me today for the latest and greatest product announcements on the UAV division. Next, I'd like to keep us moving on the ground by introducing my colleague, Mr. Josh France. He is the division manager for mobile laser scanning, and he'll be presenting on techniques to perfect the user experience. Josh, take it away.
Thank you, My-Linh, and welcome everybody. Thanks for joining us this afternoon. And we are getting ready to roll here. Let me make sure this is definitely going. Now it is. Of course, always a fun thing to do a live webinar. So welcome, and we're all going to the ground now. And this year, our focus was on perfecting the user experience. My colleague, Dr. Harold Teufelsbauer, over in Austria, has been working hard to take in the feedback from our users around the world, and North America particularly, to help make slight changes to improve everybody's experience. So let's get started. So just a quick showcase here of our two dual scanner systems. We have our VMX2HA that comes with many, many camera options, 9 in total, in fact, and the VMY2, which is a lighter weight compact system that supports some camera systems, but not all of the same cameras that the VMX does. Although now we have an ability to mix and match cameras between the two. So a great two scanner solution here. So moving on to our new updates. So user experience. So what's more user experience heavy than RIEGL, right? Well, just in case you didn't know already, we do have a great way to log data internally of the system. As you can see here, it will auto trigger the files. Then going right into RIEGL process, we've extended our batch processing capabilities to be able to do more and more right in RIEGL process using command line prompts. And to continue that automation train right on running here, we are adding a new camera alignment feature. It's coming soon to RIEGL process, and basically it'll allow you to calibrate all of your cameras, whether it's a pavement camera using some great targets on the ground, or it's the Ladybug 6, it will be able to help you calibrate all of them. Now, important note, it does require an initial estimate in order to sort of seed the orientation. So at least it's a rough estimate to start with. So those will be exciting to try out and use in the near future. And last but not least, something available now is if you've ever found it difficult to use a mouse or use a touchscreen in the vehicle, the new RIEGL operator console allows you to have nice large buttons to press on your dashboard or mount in your cup holder even, and be able to easily press something while you drive or as you monitor the system. So here's another great invention for Ladybug users. If you've ever mounted a Ladybug camera, you know it can be, we'll say, challenging at times, and certainly an exercise in strength. So as you can see here, we've modified our Ladybug mount to include a tilting option that allows you to tilt it down for transportation and then raise it up for acquisition. We've also done a nice job integrating the overall connectivity of the system, so you no longer are fishing cables through the pole. That should make it a lot easier for setups and takedowns. And then we've also included some more user-friendly connections right there on the mounting post, as you can see from these drawings. So that hopefully will be available before we know it. Moving right along, another bonus for Ladybug users is the 360-degree gapless images. So if you ever looked at panoramas before, you notice that, of course, the cutout is the vehicle and right underneath you, and you kind of have to see that in the next picture. You can see from that video fly through there that you are in fact, we'll play it one more time, seeing below the camera, right? So right below where the camera is, we're doing some post-processing in our software to be able to allow us to fill in those gaps. So I'm excited about that. That'll give you a true Google Earth Street View from your Ladybug 6 or 5+ images. So as we're talking about cameras, we're getting smaller. We're going down to a 1 millimeter ground sampling distance on our ortho photos coming out of our rear pavement cameras. So this is that two camera system mount that goes on the back of a VMX, a VMY, or even a VMQ that allows you to get very close, good details of the road surface. As you can see here from this is a close-up drawing from a normal photo, and this is from our two cameras as in the rasterized version. And you can see the size of details we're picking up there very clearly there. So this now uses 12 megapixel JPEG cameras, which allow for high frame rates. And then we've even added some more features to the ortho plugin for RIProcess. So if you'd like to get trying that out with your systems, let me know, and we can get you some sample licensing before you know it. All right. And as we head into more of the software world and get into machine learning algorithms and deep learning, as we are calling it here at RIEGL and focused on, we're adding more features. So we've already done very well with adding a face and license plate blurring feature, or anonymization, as we call it. That works very well within our software tool set. And now we're adding some classification tools to help seed that data for further feature extraction processes outside of RIProcess. So you can see the example on the right there. It shows all of the classes that are discovered in this urban environment fully autonomously within the deep learning module that will be embedded in RIProcess in the upcoming releases of our deep learning package. So that's just a little bit of the new user enhanced experience coming from your mobile team in both the United States and from Austria. We thank you for hanging out with us. And now over to something different from Tan, who works on their static scanners. He's going to give you an update on all the great revolutionary ideas and concepts coming out of that division. Let's get Tan here.
Thank you, Josh. And before I start, I want to first introduce a couple of colleagues that are responsible for the materials that I will be going over today. Mr. Nikolaus Studica, he is responsible for the TLS business division and at RIEGL LMS, and also Mr. Thomas Geitsker, our international manager in the mining business division, and of course myself, Tan Nguyen at RIEGL USA, business development manager for Terrestrial Laser Scanning. Let's go ahead and take a look at the agenda. Introducing exciting news, a new terrestrial laser measurement system, and some good updates and news for the VZ600i, and also some updates on the VZI series kinematic feature. Okay, first allow me to introduce a brand new ultra long-range laser measurement system, the new RIEGL VZ4000i. If you know the RIEGL portfolio, the previous generation long-range scanner, the VZ4000, does house the same form factors and size, but nevertheless, this new VZ4000i is a little bit lighter. Let's go ahead and take a closer look. Looking at the front and rear view, the front view not so much changes, but certainly the rear view is housing a new touchscreen, 7-inch touchscreen, very similar to the VZ600i. Also has a single button operation and 2 independent power supply connection for continuous scanning and hot swap. This is a very nice system for applications such as open pit mining and also forestry. Go ahead and moving on to some of the performance, increase in laser pulse repetition rate, and also increase in range. From the previous model, the VZ4000 only scans at max rate of 300 kilohertz. This is a 200 kilohertz improvement on the VZ4000i. Also increase in range up to 4,600 meters at 90% reflectivity natural target, and 4,000 meter at 60% reflectivity of natural targets. And continuing with the multiple returns capability, you can receive 15 returns at any selectable pulse repetition rate. With the photogrammetry, improved internal camera, 25% smaller pixel size, more images into detail, so more resolution, higher resolution, but more importantly, the image acquisition time is 5 times faster. So just give you a perspective on timing wise, the previous generation ultra long range scanner takes up to 45 minutes to complete all the images, but with this new improved internal camera, it now only takes about 12 to 15 minutes, depending on the overlap. And if you want to create a full panorama image, you get about a 5,000 megapixel image. So very nice, high quality 360-degree panorama image. Okay. Switching before we switch gears, the last thing I want to cover on the VZ4000i is the dual processor, which enables functions such as onboard registration and also customization for post-processing apps using Python scripting. So if you have the ability to write and know how to code and script in Python, you can certainly make use of this interface and capability on the VZ4000i. Apps you can develop, such as already included, onboard registration. Some other ideas would be coloration of the data or filtering and such. Open and creative to all ideas. Okay, switching gears now with the 600i improvements and ongoing developments. Here we are offering a new Sony camera, ILX LR1, which is a professional 61 megapixel full frame imaging system. Also, in addition to the new camera, this new Sony lens is a 14 millimeter f1.8 full frame lens, well suited for outdoor use and excellent performance in low lighting condition. Also new accessories to the VZ600i is a new camera mount with a GNSS receiver for the RIEGL Theta Z1. If you remember in the past, the first generation mount did not include GNSS GPS capability, but now with this new mount, you can, scanning outside, you can also pick up GPS information for your 3D point cloud. The power supply is still being provided from the scanner, which also is a very good feature because our customers doesn't have to worry about powering the camera itself. And not just for this camera, but historically, all of our external integrated cameras, the power is generated and supplied via scanner. And new mounting bracket for the VZ600i allows our users to tilt the scanner at 45 and 90 degrees tilt, and it fits it fits with compact tripod already from the 3 brands listed here. So existing customer can purchase the mount and still use it on their existing scanner. Yeah. Okay, last in the presentation covers new kinematic feature updates. And I want to start with a recommendation for high quality results. And these are simple, but yet should be met. RTK correction mandatory. This is mandatory to begin and end a kinematic project. But further in my presentation, you will see that we've had been a little bit more relaxed on the mandatory part. Vehicle speed is recommended to be 15 miles per hour. Of course, you can go a little bit faster or a bit slower, all up to user define, but the sweet spot seems to be 15 miles per hour in speed. Avoid GNSS denied area. Yep, please understand this is an RTK system and not a PPK, so try to avoid GNSS denied area at all costs. And ensure that positions for static scans when beginning and ending your mobile project, right? So it is required that the first scan to enable the mobile feature is static, and then you can do your kinematic, and then you must stop again and do another static scan. And the last maximum trajectory length is approximately 90 minutes, right? So we allow 90 minutes of scanning. In the past, the beginning stage, you're looking at about 30 minutes, but now we can increase it up to 90 minutes. All right, now let's look at a project that I want to highlight that kind of represents what we just showed. You can see here, this project distance is about 5.188 miles. Took about an hour and 7 minutes to scan. Measurements total point is 563 million points, which equals out to about 38 million points per minute. And so it's a lot of data to handle. So new trajectory and improved updates in the trajectory processing. Of course, that's one of the main and most important aspect of our kinematic feature when processing the data in RIEGL Pro is that now we're able to group the IMU data and information into less segments to increase the processing time. That's the main goal here, is to reduce processing time. Yep. So if you just go into the trajectory attributes, you can then go into the processing and change the default from 1 to 4. Okay, this will greatly improve the processing time. Next, here is same project. We do allow customers to scan in areas that have GPS floats, and also single GPS too as well. So but still, please remember that to begin a project, you must have RTK fix, and to end a project, you have to have RTK fix. But in between, you do have the ability to acquire kinematic data without being fixed, and to be floats, and to even have the single. But we encourage that it is fixed the entire time. So this is a huge improvement from where it was began about a year ago, where if the project was not fixed the entire time, it was very difficult to process the data and get very good results. Okay. Also improve in the trajectory refinement tool is the environment and scanning scenario that you're going to be working in. We understand that not every environment is perfect and ideal for RTK fix. So now we have different type of scenarios with different parameters to process the data, such as outdoor canyon and lightly stocked forest, and mining environment and such, where you would not receive RTK fix the entire time. So also a improvement in the trajectory processing tool. And a couple more things here. Here we're also able to put in the search planes and properties of the project. This is very simple to do. All you do is just bring in your kinematic scan, and you can then just measure the distance that you are interested in, right? So if you're scanning a road and the road width is 20 feet, or the whole width of the area of interest is 100 feet, then you would put 100 in max distance. That's what that means. Let's say you were doing just a little narrow corridor in a downtown area where the buildings is only 50 feet, then you would put 50 feet. Yeah. So in this case, it's 10 meters. Also the same thing with the maximum angle distance. So all you do is just put in the kinematic data. You can see that there is a yaw angle offset, which is what you'll see here. And you can just roughly measure the orientation error, which here is 10 degrees. All you do is then put 10 degrees there and then click OK. All right. Now, the ending slide, an overview of the improvements that we've made to the kinematic apps. One is the data acquisition under poor GNSS quality, which we now allow for GPS RTK float, and also single GPS, right? So you don't have to be and perfectly articulate, fix the entire project. But I don't know if you saw that or not, but if you take a look at this facade, which was scanned approximately 10 times, this is of course done in radar mode, and you can see the results. So that area selected after processing 14,000 points, 14,093 points, and within all those points, the standard deviation is just under 2 centimeters, which is very, very nice, especially in the radar mode where you have many epochs hitting that same facade. So that concludes our presentation, my presentation. Thank you very much, and I will hand the mic back over to Abby.
Thanks, Tan, and of course to all of our presenters and colleagues that put together this great information. I think that takes us to the question and answer portion of this session. We have a few great questions that have come in. If we don't make it to your question today, we will follow up with you shortly after the webinar. Let's start with airborne questions. Michael, is there an upgrade path from the VQ1560 Mach 2S to the new VQ1560 Mach 3S sensor? Passing over to Michael for the airborne questions.
Thanks, Abby. That's a great question. In fact, in the VQ1560 series, there's been a history of upgradability from the VQ series, really, in 2016 up to the present. And that's given us customers the ability to maintain that ROI for as long as they have as we reduce new sensor models. Unfortunately, we've hit sort of the wall with respect to future performance improvements with respect to the Mark 2S. And so the inherent computer architecture can't support any further increases in rep rate. And so there was a necessary redesign or migration to the new electrical system, the electronic system, to be able to support those further increases. So unfortunately, there is no direct upgrade path. However, know that the new architecture, of course, supports further upgrades and model releases moving forward.
Thanks, Michael. And a second question would be, can I replace my existing IX controller with the new VQ-IU?
That's a great question. So yes and no. So these larger sensors, the VQ1560 Mark 3S, the 12 and 1460s, they've been purpose designed to remove the data storage, the external data storage components, and put them on board the sensor. So in those cases, a controller is not required. So if you have an external data recorder associated with one of these larger, older sensors, that is still required. There's no capacity to do the onboard storage without the new sensor migration. Now, for the smaller sensors where you're using an external IX controller, there is that possibility. In fact, you can record both the LiDAR and the imagery data onto the VQ-IU. So there, we would need a discussion with us to look at each of that specific configuration to determine that path forward. But there is a path with respect to those smaller sensor configurations that we typically see in the pod solutions.
Thank you, Michael. Moving over to the unmanned division, My-Linh, how soon will the new VUX 100 with RIEGL F be available?
That is an excellent question, Abby. We are looking forward to releasing both of these new products sometime in Q1 of next year.
Perfect. And second question, what camera options are available with the UAV LiDAR systems?
So we offer quite a few different camera integrations, primarily with the Sony camera lineup. The A6000, which is a 24 megapixel camera, that camera itself has been at end of life by Sony, so we are integrating its successor, which is the A6100, It's nearly identical in form factor, and the performance is the same. So if someone's looking for a lightweight performance camera, that would be it. Also, as already witnessed on the integration with the VZ side, with the Sony ILX LR1 camera, this would be our go-to high performance RGB camera. At 61 megapixels. With the industrial form factor, it's significantly smaller and lighter in weight compared to the A7R4 form factor. And as we know, everything on the UAV side of things, everyone's chasing after smaller, lighter, increased performance. So that is what the Sony ILX camera will offer. If you're looking for a higher grade performance camera, of course, with metric calibrations, then we also offer integrations with the Phase 1 product line.
Awesome. Thank you, My-Linh. And now we are moving over to mobile. Josh, what are some interesting mobile projects or applications that you've heard about in the past year?
Well, thank you, Abby. What a great and thoughtful question that is. So I've heard a lot about our users and what they're up to out there. I have to regularly check into folks, and so I apologize now if I don't mention your project, but I can't always remember them all. But what I know, there's a couple large area statewide collects underway by several users, and I was really fascinated recently talking to one of our users about a great collection they did in Chicago, where they had to combine not only the VMX data collection, but also use the tripod scanners such as the VZ 600i and 400i to add supplemental data to it to be able to help control it in those areas of very interesting cross flyovers and overpasses that you have in the urban core of Chicago there. So that was a really fascinating project to hear about.
Great, thank you. And the second question would be, is the VZI kinematic solution going to take over traditional systems like the VMY series?
Well, as you know, the VMY series is our lighter, compact style scanner that is mainly just used for mobile mapping, and they are on the lower cost side of the equation. But they also are strictly for mobile use. While there is some dual use capacity with the VMY1 to be able to take the scanner out and mount it on a UAV LiDAR system, when it comes to using it in other ways and other locations, you're somewhat limited by needing to always have a power source as well as a spot for the power supply box and a bigger mounting interface. And so really the kinematic eye solution does provide a lot of advantages over that when you just can use the scanner itself with its built-in battery pack on the 600i or the add-on battery pack with the 400i. So with those two solutions, it's a really nice add-on to be able to do a small, short project. Because right now you're really limited in terms of length of time on the kinematic app. About a half hour is the max you can really go in a single trajectory collection, and that makes sense for some really small projects, and it certainly does reduce the footprint that you need to bring with you to a mobile project, just to a tripod and the sensor itself for the most part. There's also the RTK solution and things like that. So in areas of simple GPS setup or great, excellent GPS coverage and RTK coverage, it's a really good solution. However, there are definitely some challenges still to work out before it directly competes too much, I would say, with the VMY solutions.
Yeah, if I may add to that, I don't believe so. I don't believe it's going to be a takeover, right? Because you're limited by a couple of factors. One is speed, right? So with any of the mobile system that we offer, speed is key, right? We can drive on roads, highways. That's very limited to the I-Series kinematic feature.
That is correct, and good point. One of the taglines I'm going to push this year is on the VMY2 and the VMX2HAs, you can collect at speed, meaning the speed limit of the road, and do it with confidence on those two systems. We're not there yet with, of course, the kinematic solution.
Thank you, Josh and Tan. I'm just going to jump back over to Unmanned for just a second. My-Linh, a question came in, is there a Topobathy UAV model available?
I can take that question. Abby, absolutely in the UAV space, yes. So we have the 840 series. The original was the G, which was really designed more for heavy lift drone applications. And then the GL was a subsequent lighter weight version of that. And now there's a GE, which is really sort of a more cost-effective system that is really dedicated for the UAV space. For those that are looking for a system that can operate on both drone and in helicopter installations, then we would push clients towards the GEO. And of course, we do have larger sensors available, but if the questions are specific to the ULS installations or the drone installations, the GE and the GL would be the sensors to consider.
That is correct. Thought I had unmuted myself, but apparently didn't. So to adding on to what Michael has provided, we have already had very successful integrations of our Chopabathy lineup on a variety of UAV platforms, including Harris Aerial, Ace Core, Free Space Operations, and Velos Rotors.
Great, thank you, Michael and My-Linh. Heading over to the terrestrial division, Tan, when is the VZ4000i available?
No, thanks, Abby. Yeah, good question. It's available in 25 now. Unfortunately, we don't have a confirmed time exactly, but you're looking at beginning of next year, 2025.
Great. And the second question would be, can the kinematic feature be used on a boat?
Yeah, absolutely. Boat, your typical vehicle, ATV, a bicycle. It's a really first of all, it's a really neat feature, right? So, and I also want to emphasize that, hey, this is a 600i to 400i first terrestrial scanner first, okay? So that's a fact, and then the feature, the kinematic feature is second. Yeah, but the flexibility on it's in this. You can mount this thing just about on any time of moving platform.
Great, thanks, Tan. Okay, I think that's about time for the question portion. We want to stay on schedule to respect everyone's time here. Thank you so much for joining today, and we look forward to more discussions with all of you on our continuing innovations and latest in LiDAR advancements. Be sure to sign up for our newsroom at www.riegle.com. We will be posting the recording of this webinar very soon. And for those that wish to see this webinar in Spanish or Portuguese, we will be sending that info right to your inboxes. Once again, thank you so much for joining us, and we will see you all next time. Have a great day.